I focus on automation and on threat hunting.
That sounds like a fun game, threat hunting.
No, I didn't have the nuts to do that.
Quantum computing, basically to tell people that they shouldn't be as worried as...
You guys are so much fun. Do you do this only in the Netherlands, or do you go, okay, we don't actually notice what they're doing?
No, we don't even see it.
Yeah, I know.
And we are at the security convention in the Netherlands, in Utrecht. And as you've seen probably in the session before already, we have some real smart people talk about security and security technologies and solutions and how that applies to your daily life. Now, the next speaker is going to talk about something quantum again. And I was asking for this one because I have no clue what it really means. So I hope that Sander can actually help me understand quantum.
Oh, that is gonna be a challenge, but I'm up for it, so let's go.
So, Sander, welcome here at SECCON. Welcome at
thank you.
The Basement series, Out of the Basement. Today you were a speaker about quantum, but what about quantum you were talking?
So basically I was talking about quantum computing, what we from Fox IT are expecting to see in the future, and basically to tell people that they shouldn't be as worried as the internet tells them to. We see a lot of improvements in quantum technology, in quantum computers, but we see more improvements in post-quantum or quantum resilience. So you see...
What does that mean?
It means that, so you have the idea of a quantum computer, and basically the idea is that you could break something, stuff like RSA and ECC, which are well-known cryptographic algorithms.
Yep.
So, and that's basically it. That's the black box. A quantum computer could break those algorithms.
Yes, because the quantum computer is smarter than and make bigger, faster calculations than those algorithms. Yeah. Okay.
This is everything about that is really into the future, but the idea is, and the math is here, that you could use a quantum computer to break these algorithms. However, a lot of people saw that and thought, well, what if we make an algorithm that cannot be broken or cannot be calculated faster by a quantum computer? And that's something that has been going on for a few years now, and that's something that's going way faster than the actual quantum computer. So my talk is really about the fact that even though a quantum computer is coming, and you should of course always be prepared for a new technology, you got to be agile when it comes to cryptography. You don't have to worry that much. You do have some time before these things start moving, and depending on where your stuff is, if you're in Azure or if you're in AWS, well, maybe it's just a checkbox that will appear in a few years that will say, do you want to be quantum proof? And then the problem is solved.
Okay, because then it will take those resources from a public cloud offering.
For example, if you're looking at the algorithms that you're now seeing now, for example, RSA, ECC, stuff like that, there are already replacement algorithms that could do the job as well.
Okay.
There are technical challenges, but nevertheless, the algorithms are there. So if you can replace the old algorithms with the new ones, you're basically done.
Wow.
It sounds very simple, and it isn't, but that's where the problem, that's where the solution starts.
So how does this technology or this evolution already apply to our daily life as it is today?
The biggest challenge that we see right now is that data that you steal today, you could save up, keep it safe somewhere, keep it stolen, and then once a quantum computer is there, you could use the quantum computer to break the stuff from the past. And this isn't really much of a problem when it comes to the stuff that we handle daily. For example, a bank transaction, maybe it's not that relevant in 30 years or 20 years, but for example, people that are police informers, and a list of names, and a list of aliases, or maybe government secrets or company secrets or medical journals. That's the kind of stuff that you want to keep secret for a very long time. And for those kinds of use cases, the problem exists right now. Because if I steal your medical file today, I could wait 5, 10, 15 years and then embarrass you with what I found in the dossier 15 years ago.
Yeah, there's quite a lot of things to embarrass me with. Please keep us safe, yes. So what are already things that our customers and in businesses need to keep an eye on, and how can they already protect themselves? I mean, this is a wide question, but this is the quantum computers and the breaking of algorithms is a threat. How can they already protect themselves?
Well, there's two things, I think. First, a lot of software already comes with optional post-quantum or quantum resilient algorithms.
Okay.
Looking at OpenSSH, OpenSSL, those are the kinds of libraries that already have post-quantum algorithms in them. They're not always enabled, they're often optional, but they are there. There are also a lot of libraries, for example, Bouncy Castle for Java and similar libraries that already have these post-quantum algorithms in them. Many of those are still in development, but it's something that you can experiment with just to see what would happen. If you're running, well, again in Java, if you're running WebSphere, can you upgrade? If you're running a web server or a network server, can you use post-quantum algorithms to open SSH into a server instead of using ECC or something similar? And that's the first thing that you can do already, which is basically experimenting. And the second thing is more about the organization itself. It's trying to find where your vulnerable data actually is. And this is more something for maybe a CISO or maybe an organizational kind of a thing. But if you don't know where your treasure trove is when it comes to your data, then you don't know what to protect. But it's more of an organizational thing, but there are already a lot of technical advances when it comes to quantum resilience that you could at least experiment with today.
Good. So where can people go to if they want to learn more about this, want to start for it themselves, to see if they need extra protection? Where can people go?
Well, a very good resource is the openquantumsafe.org, where you can
openquantumsafe.org. Okay.
Where you can find a lot of libraries, a lot of code, a lot of experiments from people that are building quantum resilience into the tools that they use daily. So it's the libraries that I mentioned before, but also new ones that they can use to see if it works for them. Similarly, Cloudflare, well known, is currently offering an experiment where you can link a subdomain on your own platform to their post-quantum front end. So if you connect to Cloudflare, Cloudflare would connect to you using post-quantum algorithms. So you can see if your systems are actually up to the task of running something with post-quantum algorithms.
Wow.
I wouldn't do it in production, but it's something that you can try right now and see what happens on your system when they have to connect back using a post-quantum algorithm.
That is a very interesting exercise to do, yes.
Yeah, and that really shows you that the proof of the pudding is in the eating. You can really see if your systems are actually up to the task. Similarly, you could try upgrading digital certificates, not just from RSA, RSA 1024 to RSA 4096. You could also see what happens if I try to upgrade it to a post-quantum algorithm and see which systems break when you do something like that. See what happens when you replace your OpenSSH keys, not an ECC pair, but try a Kyber pair, which is a post-quantum algorithm. Just see what happens and you'll be surprised where stuff breaks, but also the stuff that is already quantum resilient.
Very interesting, very interesting. So, Sander, the basement series started in my basement during the pandemic. And we always have a few questions that I ask everyone. And one of the questions is, tell me about your home network, your home setup.
Oh, well, it's not quantum resilient for one.
Okay.
This is something that I'm playing with myself as well. I started a few years ago with a stack of Raspberry Pis that I upgraded and upgraded and upgraded. But at a certain point, I realized that a lot of software, when you try to run Docker containers, isn't really in our ARM images. So now there's a little Intel NUC next to it. A lot of stuff is pretty much consumer grade Ubiquiti and Unify. And I'm starting to experiment with cameras, and then I need a network video recorder, stuff like that. But all in all, it's pretty basic. A couple of VLANs for the cameras, a couple of VLANs for the IoT stuff. But like I said, it's all in the house, behind the firewall, but not yet as quantum proof as I would like it to be.
So if I ask the same question 3 years from now, will you quantum prove it?
Yeah, absolutely. Yeah, for example, there are a few algorithms now that have real implementations. They're not very good, but they are there. And that's something that I want to experiment with at home. And for example, something like OpenVPN or WireGuard, those are tools as well that are starting to move towards post-quantum algorithms. Nice. I'm pretty sure that if I finally get my own VPN working, because I'm still fighting with the DNS, is that it's going to be a post-quantum proof variant.
Very interesting. Yeah. Very interesting. Cool. Last question. Tell me about a day in your career that you will never forget.
So, you know how you should never mix production and test environments?
I definitely
This is something
know that,
that everybody knows. So I have worked at a bank where, due to the system setup they had, they were basically forced to run test environments into their production or in their production networks.
Okay.
And they had this weird mix of test and production where they had to run their tests in a production-like environment, and that meant that they did them on production as well. Of course, this went horribly wrong. I was called on a Monday morning. They had accidentally sent $4 billion.
What? With a B, ladies and gentlemen, with a B.
Yeah, the billion with a B, twice. Once on the test network and it worked, and then on production where it also worked. And that's the day they lost $4 billion.
Oh my God.
They got, this is a lot of money, and this is from clearing houses. So what you would do as a bank, and you have another foreign bank, is that you don't send all the transactions during the day. You just save them up, you count them, and you send the difference. And at the end of the day, the difference can be pretty big.
Big, yes.
And they sent the difference twice to a number of banks, and I think they got most of it back, save for a small amount of $200 million.
Wow.
And that's the most expensive mistake I didn't make that I've seen.
But you were part of the team where it happened.
Yeah. As I was responsible, among other things, for cryptography, and this was also about digital signatures, signing transactions, validating transactions, and validating signatures. So they called me and they asked me what went wrong, and I said, well, this is a test key that shouldn't have been accepted by a production environment, of course. Also, there was an entire discussion on how in a test environment you shouldn't use valid IBANs, so bank numbers, but they mixed up production and test, and it cost them a lot of money.
Oh my, that is a great story. That's very interesting. Wow, that must have been an impactful day for you. Yes.
Yeah. There was a lot of phone calls and a lot of higher-ups and a lot of suits suddenly dropping by to see how we were doing. Luckily, most other organizations were pretty relaxed and send the money back. With amounts like these, ironically, money becomes stuff.
Yeah.
So it was mostly recovered, but when it's gone, it's really gone. Yeah.
So lesson learned.
Oh yeah. Yeah.
Don't mix test and production networks. With that, Sander, I think it was a really good and interesting session. Thank you very much.
Yeah, thank you
for your time. And yeah, I'm looking forward to see you speak another time on another event.
Oh yeah, absolutely. If I have an update, I'll send it to you. Once my network is post-quantum proof, I'll be sure to drop by and tell you how I did it.
Sounds great. Thank you very much, Sander from Fox IT. Thank you very much.
Thank you.